going to do the access controls and the first bit of data stores, which is going to be pretty easy because you did the web, you've already done a SQL injection project, and we've done the SQL injection demos, so you've already seen a lot of it. And then I'm going to demonstrate some more of the SQL injection. So that's the plan. So let's start with Chapter 8, which is a short chapter about attacking access controls. All right. So access control, as you know, first you have to make sure you know who somebody is, usually with a name and password. And then, after you know who they are, you have to have session management to continue to keep track of who they are as long as they're using the app. And then you have authorization based on that. After you determine who they are, then you have an access control list of what they're allowed to do. And you have to check all the time to make sure they're authorized to do what they're supposed to do. And it is extremely common that you have the vulnerability called insecure direct object access, where somebody can access something and you forget to check who they are first, especially in APIs. This is really common in application programming interfaces, that you have various services available and one of those services does not check who you are. It's very common, and it's, I think, a very common source of data breaches now, is unprotected APIs. You must check for every request and every operation. You must go through your access controls and your authentication, your authorization, or you have an open service available to the whole world. And, maybe you do have certain services you want to make available to the whole world, but you should be doing that deliberately, not by accident.
How is API affected?
How is API what?
Affected?
Well, API just is the current highly vulnerable version of this. And the reason is people write things like phone apps, and the phone app does something like make API calls. Like you have a Facebook phone app, and it sends a request to get like your recent posts on your wall and your profile and your picture. It's making requests of the server, and the developer that designs the app will very often make the same mistake that web developers make. They will control security inside the app on the client side. And so the app will not have a feature to look at somebody else's profile. But the fact is, if you capture the traffic with, say, Burp and replay it to go to somebody else's profile, you're in fact able to get private information from somebody else's account because they're not really verifying who you are in the server. And this happens to web apps and phone apps all the time. And APIs, the reason why APIs have it happen more often, I think, is because it's invisible. Many developers don't realize that there are tools you can use to make unexpected API requests like Postman and Burp. So they think if they don't give you something to click on in the app that makes that request, nobody will make that request.
So the developer didn't use the developer using the API didn't access this guy?
Yes, the developer did not really test it for every request and operation. This happens a lot, and we'll talk a little bit more about why. But it's easy to see from the organization of a company why this would happen. We'll get there. So here's the common, you have vertical and horizontal privilege escalation, and then context-dependent vulnerabilities. Vertical privilege escalation is the normal one we think of, where you escalate from a user to administrator. So that's one possibility. For example, you might have an administrator page that forgets to check who you are, so all people have to do is guess the URL and go there, and they're accepted as the administrator. That happens fairly often. And another thing, of course, is if I can horizontally move over and see another user's stuff, like a different user's email or something, is the horizontal privilege escalation. And then there's business logic exploitation, where I can do things that should not be possible in context. For example, if I can skip over steps and do things out of order. So if I log in, then I enter a credit card, then I buy something, I enter the credit card, and then I put in shipping information, I might be able to skip over the payment step and go right to shipping and get the product shipped to me without, in fact, completing the payment step, this sort of thing. Then, of course, this is what I've been mentioning, completely unprotected functionality, unsecured direct object access. This is also called security through obscurity. You make an all-important URL, like the administrator URL, and you just think that people won't guess it. So it's not actually protected by authorization, it's just hidden by being difficult to guess. And this sort of thing goes on all the time. So here you have an example. There's some secure thing that does an administrator thing, and they just think nobody will find it because it has a funny URL. But of course, people often do find it. Let's see, someone says, found this in a new job that he got recently. You authenticate, get a token, and after that, the app was not checking for who you are, just if you have a token or not. Yes, That kind of thing is quite common, that it doesn't check at all, or it doesn't check thoroughly to make sure that you really are the person that should have access to what you're accessing. So even if the app doesn't contain a link to the URL, you can find it with client-side code often, and there are crawlers that find them. There's one from Google called Skipfish, and as you might imagine, Google's crawler is very good at finding all the links on a page. All right, so then here's one, for example, where you can view documents and you just put in an ID number, and there was a service that sold documents, and you would pay for a document, and then it would just give you the link going to your document, but this was unprotected, because of course they didn't keep track of all the people that had bought it and have a list of all the people. They wanted to make it available to all their paying customers, even if they come in later. So the easiest way to do that is to just make this unprotected and just give you the URL and say anybody that has the URL is authorized to see it. This might, in my opinion, be even a sensible business decision if you want to do it, but you have to consider what you're doing. Anyway, that was the point here. And the reason this happens, like I'm saying, is often because you add a new feature to your app and it's on a different server, maybe even a different cloud provider, and that server doesn't really have easy access to your authentication structure on the old system. So it's difficult to go through the authentication step, and it's much easier to just provide unprotected functionality. So in practice, to reach your deployment deadline and ship it on time, it would be a lot easier to just use security through obscurity than to go through the difficult technical and bureaucratic obstacles to fully integrate this feature with your existing features. I think that's why this happens so often. So, all right, the identifier might be predictable, and people might find it in logs or many various places, or in the referrer links and things like that. And once they find the URL, then they can get in. And then, of course, there's multi-stage functions like you select a new user, then a department, then a role, then you enter username and password, and maybe I can skip over steps. So maybe I can skip from this step right to this step without selecting a role, and then I'm something like the administrator because the role defaults to 0 or something. That sort of thing can happen. And I mentioned this, you pay for a book and then they get a link, but there's no actual protection on the link, so I could share copies of that link with other people, put it on a bulletin board, and then everybody could get a free copy of the book. This sort of thing happens all the time. All right, and then I might have restrictions to certain paths, for example, in your Apache configuration file, and that would be fine. So you can, the problem is usually if you want to block a certain URL, then you typically, like an Apache configuration file, you can't block just a URL, you have to block a method. And if you forget to block all the methods, you can use a different method to get at it. So, for example, you might only block posts, but they can use get to get in there, or they can use head to get in there. Head is often implemented by performing a get, and even a misspelled verb like GETT is often interpreted as a get and processed as a get by the server, so the misspelling might cause it to pass the security rule, but it'll still in fact get the resource. So, all right. So there's other ways, access control methods like a parameter-based, referrer-based, or location-based, and all these are insecure. So parameter-based will just have a parameter sent up, like admin equals true, and of course that's under the user's control. They can just add that parameter to another request and be treated as the administrator. Referrer-based would use the referrer to see if they come from your page, but as you know, the referrer can just be modified with a tool like Burp, so I can make a request that looks like it came from your page when it didn't. And the same thing with location-based access control. I can use a VPN or a proxy, or indeed find whatever you use to determine the location, like the GPS, and just hack that on your device. You don't really know where people are unless you think this through very carefully. And so anyway, Burp has the ability to check for these things. You can compare the result of two user accounts. You might want to see if one user has more privilege than another. And so it has a sitemap comparison where you can log in as one user, serve a bunch of objects, and then examine the same object logged in as someone else, and Burp can compare them and highlight the differences. So you can see what pages of an app depend on who you are and determine if they are the way they should be. So here, a low-privileged user is denied access to the admin page. So one of these is administrator and the other isn't, and the difference shows that the administrator page cannot be reached. But here, a low-privileged user can access an administrative object and see a table they're not supposed to be able to see. All right, so to test these things, you might be able to guess methods from ones you can see. So here's a post, and this indicates that you're using IBM server. You can see it here in this servlet for a property. Tells you what you have, and that would give you a clue. And if you know that, then you might be able to guess other things to try. All right, so here's how you test this. Walk through while logged as administrator. Note the URL of high privileged things. Log in as a low privileged user and go back to see if you can access them. Of course, that will tell you if you have pages that are not enforcing your administrator role. And find sensitive requests and try other methods. Post, head, get, and an invalid verb, a misspelled verb. And so don't rely on users' ignorance of a URL or identifiers. You can't expect these things to remain secret. Don't trust anything that came from the user. Don't assume users will access pages in sequence. The way to make people access the page in sequence is to put a random hidden variable on every page and verify it so you make sure that they came from the page before this every time. You can force that, but if you don't force it, don't assume that they'll access pages in sequence. And of course, don't trust them not to tamper with data. Any data that comes from the user should be revalidated on the server. Unless, of course, you put it in something like a signed ASP view state. That you can trust. That's cryptographically signed. But anything else could be tampered by the user. Anything is not protected cryptographically. So the best practices are document your access control requirements, make sure that all access control decisions come from the user's session, so they apply to every request, and write a central application component on the server to check access controls and use it for everything. Don't have scattered code on different servers, different apps to do the same thing, because of course it'll be hard to keep that updated. The best way is to have one central component. Like in Windows, you have one domain controller, and it controls all authentication and authorization. All right, and so you might add other second factors like IP address or something. And all right, don't trust identifiers from the client, and consider adding another reauthentication step for really critical things, like creating a new payee. And log things, log events that use sensitive data and do important things, so you can see if there's too many suspicious requests coming through. All right, and so I mentioned central access control. Everybody in the Windows world knew this. Microsoft invented domain controllers in the 90s because they found out that this is enormously important to have one central location to handle security things like usernames, passwords, and authentication. And the same thing applies to web apps. You should have one central access control system that's used by everything. Now it's easier to maintain. Everything is consistent. And now you can adapt to it. You'll have less mistakes. And so you can have a complicated matrix like this where you have different users, company administrator, auditor, site supervisor, and each user has different access to all the different parts. This is what you'll see on a Windows domain. You'll have all these categories of users and all these different privileges for everything. This is what you really need for the complexity of a real business. And you really can only do this with one central server managing all these applications. If all these security decisions are made by scattered code all over the place, you'll never be able to make it efficient and secure. All right. And I had a PHP example, but it's not very interesting. Just I'll mention there is a theory. If you don't use triple equals signs in PHP, then it is comparing, but it changes the type of data without telling you. So if you were to have an MD5 of a password compared to a static like this is a hexadecimal value that contains only numbers and no letters. That is in fact extremely rare. But if you were to have a hash value like that, PHP will not interpret this as a string, it will interpret it as a number. 0 times 10 to the 199 trillion, so it's always 0. So a whole bunch of different passwords that hash to a similar thing will all be equal. This is a vulnerability that became sort of well known a few years ago, and I thought it was pretty exciting, and then I realized this is extremely rare. It's very unlikely to happen. So anyway, I made an example, but it's not really worth going through. Anyway, let's try a Kahoot, which is chapter 8 here. All right, maybe we got everybody we're going to get. All right, so which attack accesses pages out of order? Yeah, they call that logic exploitation, defeating the logic, the business logic of the app. All right, what attack is it if you read another person's email? Yeah, that's horizontal escalation, moving over to a different account with the same privilege level. All right, what technique is security through obscurity? That's unprotected functionality. Where something is not protected, it's just hidden, and you imagine that attackers will not be able to find it. All right, and what defense do you bypass with a proxy server? That's your location. You can change there. All right. JZ, I don't know who that is. I think that's real initials. Who could be, all right? Pete, B. And, good. I think we know who these people are. And I can see your thing not working too well. Kim, you might try a different browser. Yeah, anyway, so, all right. Yep, JZ, good. That's what I thought. I'll make a note. All right. All right. So, let's go to the Chapter 9 slides, which is going to be pretty easy because we've already pretty much covered it in the projects. So, this is the first bit of data stores. The main type of data stores are SQL, Structured Query Language, XML, and LDAP. And all we're going to talk about today is SQL, which you've already exploited quite a lot. Until a few years ago, it was called the #1 vulnerability in web apps, and they said almost all stolen data had been stolen through SQL injection, because very often you can easily dump the entire database from the server. I believe that is no longer true because of unprotected Amazon buckets, which have made it even easier to steal lots of data by just having vast amounts of data completely unprotected for years. But anyway, it's certainly a huge problem, a high priority vulnerability. So this is the problem with injecting into interpreted contexts where you're putting in data and the data is used to create a line of code which is then fed to a server which interprets it as if a user had typed it in. That's the fundamental flaw here. So code is not compiled, it's executed line by line, and there are many core languages like SQL, LDAP, Perl, PHP, Bash shell scripting, Python that can execute code in this fashion, and it's a poor development practice that a lot of people do. So you've done this, I think, in the projects where you have a code that just says ping whatever I put here, and since that's a line of Bash command, you can just put a semicolon and another command there, and it will execute it. And that's a simple case of command injection into Bash. And now if you have compiled languages, this is more rare because you can't just inject code in a high-level language like Bash shell scripting or SQL. You have to inject binary machine code, and that's what we're doing in the exploit development class. You can learn to do it, but it's more difficult, and not very many people have that skill. So, for example, if you have this kind of thing where select from users where username equals Marcus and password equals secret, but this username is under my control and used without sanitizing, then I can put in admin apostrophe, and then I'll also have to have a dash dash here, which is very strange that it's missing. Dash dash there. Oh, I see. It's the stupid thing is changing it. All right. Anyway, so you put in admin apostrophe dash dash, and now the command is select star from users where username equals admin and the rest is ignored. So you get in without testing the password. It's one of the many common SQL injections. And so you can put in this if you don't even know the username of the admin, and then it'll be username is blank or 1 equals 1, so it will authenticate as the first user in the database, which is typically the administrator. You don't need to know the name or the password. All right. And so we talked about this. You've been doing the hands-on SQL injection projects. Union is what combines two select statements. So you can add a second select to the first one, and therefore you can do things like this, where you union things, select SSN. So, and you've been doing projects like that all along. You need a comment character frequently, and as I just learned from the BERT project, space, dash dash space is almost always accepted as a comment, but without the spaces, it often isn't, and you have to use the pound or a slash star. You have to find the right comment for the type of database you're attacking. And for union, you have to have the second select query must give the same number of columns as the first one, and they must be compatible data types. You can't have a numerical column and then put text in that column. So if you have the wrong number of columns, you'll get this. The use select statements have a different number of columns. If you're able to see the error messages, which you usually are not, but if you can see it, that is the error. And if you have different data types, this one here has a text, and then you put in numbers. Now that works because numbers can be treated as text, but the opposite does not work. If it's numbers and then you put in text, it will not accept it. All right. So here's the steps. First, you find the number of columns. You try union select null, 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 because null can be added to any type of column, and you find the one of these that doesn't complain about the number of columns. Now you know how many columns there are. And then you can try putting text in here to find out a column that contains text, which is usually what you want, so you can pop out whatever you've got. All right. This is how you find a string column. You put a string in there and try them. All right. And so you can find database version with a command. It depends on your version of SQL, what type of database, but you put in something like add version. And here's Oracle. You use banner from this table, and we've talked about this in the on the SQL cheat sheet in the Web Security Academy. All right. And this is really out there. Remember, this was a San Francisco college that had a SQL injection where you could just get the administrator password hash, and I tried to get them to care. I couldn't get anybody to care. I tried contacting them for years. Anyway, this is generally the case. If you find a vulnerability on somebody and they don't have a bug bounty program, just don't waste your time. Just let them get hacked. The chance of communicating with anybody is essentially zero. If they don't have a bug bounty program, you will never find anybody that understands security at the company typically. You're just spinning your wheels. Anyway, so MS SQL is here. So your name equals Matthew gives you a name and an email. And if you find that you can inject things with an apostrophe, then you do the select null and try to find how many it takes. And it turns out you need 5 columns to get it in. So if you put in null, 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 then you'll get 2 empty fields here. So that tells you have 5 columns. So then you find out the first one is an A, because the A goes here. And so now you can just ask for things like table name, column name from information schema columns, and you get table and column names. Or you could combine them with concat to put them both in the first column, as we've done. And then you can ask for username, password, now that you know the names of tables and columns. So that's the sort of thing we're doing all the time in the Web Security Academy. So I think there's another bunch of Kahoots about that SQL injection stuff. Oops. Okay. All right. I guess we're okay. All right, so what SQL method do you use to combine 2 queries together? All right, union, good. All right, so what's the point of this null null stuff? Yep, that is how you find the number of columns. All right, what's the free open source database? MySQL is the free open source one. I think now the most common version is called MariaDB. These are both commercial, proprietary. All right, so if this succeeds, what have you learned? Null, A, null. Yeah, the second column is a string. It'll accept an A. All right. All right. Repeat winner. And let's, I think, face and fidget cube. You might know who that is. I think I might have seen that before, but I'm not sure. All right. We stop the recording.